Heavy. Okay. Code today is SXXHPW. Alrighty. So first one is putting the two things we learned about on Wednesday together. You need to tell me what this -2 does to the graph, what this +2 by the x does to the graph, and then, graph it. I'll give you 3 minutes to try it, and then we'll go over it. Okay. Let's do it. So can anyone tell me, we have an A value of -2. What does that mean? What does that do to the graph? What do you think? Teresa, do you remember from yesterday what the A value do? Anna?
There's a
It's the amplitude. That's the key thing. The amplitude. So that tells us our amplitude is 2, which basically means instead of bouncing between -1 to 1, we're going to bounce between -2 to 2. Okay. It does one other thing. What does the negative do to our graph? You think, Ty? Yes. So instead of starting going up, we start going down. It reflects it over the x-axis. Okay, very good. What does the b value tell us? I'll do this one. It's my turn, I suppose. B value tells you the period of the function. And you have to use a formula for this. The period is 2 pi divided by b. So for our problem, that'd be 2 pi divided by 2, which is pi. So basically, that tells us that the cycle for this time is not going to be from 0 to 2 pi, it'll be from 0 to pi. All right, so we're then going to use this to graph. You don't need to write this part down, but this is what the basic cosine graph looks like. A basic cosine graph goes from 0 to 2 pi, and it has critical points at pi and pi over 2 and 3 pi over 2. Cosine starts at its maximum, and then it follows this pattern. Intercept, minimum, intercept, back to the maximum, completing the cycle. So it looks like that. Okay. Ours, so that's a basic cosine graph. Ours were different from that because it's going to go from +2 to -2. And also it's going to end at pi. So again, to find my critical points, I need to break this up into 4 sections. Halfway point would be pi over 2. Quarter way point would be pi over 4. And then the 3/4 way point, or halfway between these two, would be 3 pi over 4. Another way to get those interval markings here is just to take the period for your function and divide it by 4. That tells you the interval for your key points. Period divided by 4. All right, so cosine, again, would normally start at its maximum, but because we're reflected over the x-axis, instead we will start at the minimum. And then intercept, maximum, intercept, minimum. So we get a function that looks like this. Okay. If at this point right now, you are 100% lost, there's a saving grace. This is how we get this answer by hand. Another way you could get this answer is to just graph it on a graphing calculator like Desmos.com. It's also a great way to check your answer. So if we graph y equals -2 cosine of 2x, you will see it starts at 0, -2, like we said. The first intercept is at pi over 4. It then has a maximum at pi over 2, 2. Intercept again at 3 pi over 4, 0. And completing the cycle at pi, where the y value is -2. So we can see not only did we do it right, but also if I'm taking the quiz or test and I'm like, oh, I don't exactly remember how to find the period. I know the b value is this, but I don't remember what I'm supposed to do. You can always graph it and see that it completes a cycle in 1 pi. Okay, questions on this? All right, so I know again what you're thinking. All right, that sounds pretty easy then. I could just use a graphic calculator to check it. You should keep that idea because we're about to make these problems harder. So they will become more difficult to graph these by hand, but you can always check your answer with the calculator or find the graph with the calculator. All right, so we did these things yesterday. Today, we're going to talk about the C and D values, what they do to the graph. And that is your translations. And also how to model real life data. That last point will be super quick. All right, so as a review from yesterday, remember any sine or cosine function can be written in the form of a sine of bx plus c minus d. Is that right? I think it said minus, right? Not plus. To be honest, it really doesn't matter because this is a periodic function. I just want to be consistent. You know, I think it's minus. Yeah, they give it to you as minus c in the book. Minus c. Okay, so a sine of bx minus c plus d is how you can write any trig function. So today we're going to talk about what does the c and what do the d values do. The c value controls your phase shift, which is how far your graph is translated to the left or right. Again, there is a little catch. Because the period of the function changes based on b, the phase shift is really going to be c divided by b. So the left endpoint of your cycle, or where you will start, is when x equals c divided by b. That's where you start graphing. You will end when x is equal to c divided by b plus the period. Right? Once you've gone through one period, that should be your ending point. So for example, if we wanted to graph this one, again, we're going to break it up into our parts. This is A, this is B, this is C. So A is -3. Again, that tells us two things. It tells us that the amplitude is 3, which means we range from -3 to 3. It also tells us, because it's negative, that we reflect over the x-axis. Our b value is 2 pi, and that tells us the period or how fast we go through each revolution. And again, you have to use a formula where period is 2 pi divided by b. So for our problem, that would be 2 pi divided by 2 pi, which is 1. Okay, our C value is -4 pi. Again, because the formula is a sine of bx minus c, the only way a plus gets right here is if c is -4, because then minus a negative is a positive. I will tell you that if you mess that up, it's not a big deal because it's periodic. So you'll just be graphing a different portion of the graph, but it'll look the same anyway. So at least for these problems, that's nice in that if you mess up the sign, it really doesn't matter. All right, so the C value tells us the phase shift, which is C divided by B. So that's, for our problem, -4 pi divided by 2 pi, which is -2. Okay, so that means I'm going to start graphing this when x equals -2, and I will end graphing it when x equals -2 plus 1, which is -1. All right, and now I have all the information I need to graph this by hand. All right, so it's going to go as high as 3 and as low as -3. I'll start at x equals -2, and I will end at x equals -1. During this interval, I need to break it up into 4 sections for my key points. So halfway between these would be what, -1.5. A quarter of the way would be -1.75. And 3/4 of the way would be -1.25. Or again, I can find those intervals by taking the period, which is 1, and dividing it by 4. That's your interval. Every quarter, you should move from one key point to the next. All right, so now we're ready to start. Cosine starts at its maximum, but because we're reflected over the x-axis, instead we will start at the minimum. And then we'll do intercept, maximum, intercept, minimum. So your graph ends up looking like this. It's a pretty skinny graph this time. And again, at the end of this, you might be like, wow, I have a dull headache coming on. That means you're doing it right. But to make sure that you did it right, we can always just go to Desmos or our graphic calculator, type in, and what you will see is, see how skinny it is at -2 where we started. Start at -3, that's right. Then at -1.75, we were at 0. And then at -1.5, we were at 3. And then at -1.75, we were back to, or 0.25, sorry. We were back to 0. And then at -1, we were at -3. And if you accidentally said that this was a +4 pi instead, so that this was a +2, you would have just graphed the portion of the graph over here instead. And really, you'll still have an appropriate graph of cosine, because this is going to continue in this pattern forever to the right and forever to the left. All right. Questions about this? Okay, I will say you might be tempted to say, Mr. Lake, it's so much easier to graph it. Why did I just do that at the beginning? The only reason I will tell you is because on the ACT, they generally won't say graph this and then give 5 graphs. It takes up a lot of space. Usually what they'll say is a cosine function is defined by y equals -3 cosine. Tell me the amplitude, right? Or tell me the period, or tell me what's the phase shift, right? They'll ask for a part of this instead. So when we're doing these by hand, we're practicing how to find all those parts. So, but ultimately, if it just asks you to graph, then sure, use a calculator. You'll be fine. All right, try this one. Graph y equals -1/2 sine of pi x plus pi. And then double check your answer with the calculator. I'll give you 3 minutes to try it on your own, and then we'll go over it together. By the way, while you're working, I've had 2 people already so far said, hey, Mr. Lake, can I retake that quiz? And yes, you can. So if you are in that position where you're like, oh, I didn't do as well on that as I hope, you can retake it whenever you like. Just let me know. I'll get you set up. Okay, let us go over this. So can anyone tell me what the A value does? It's the amplitude. So that tells us that we have a range from -0.5 to 0.5. What about the fact that it's negative? What does that do? Reflect over x. All right, our b value is pi. What does that tell us? That tells us the period. And again, we have to like do a little formula, 2 pi divided by b, which for our problem is 2 pi divided by pi, which is 2. Our c value is negative pi. So what does that tell us? The phase shift, which is like your horizontal translation left or right. So our phase shift is c divided by b, so it'd be negative pi divided by pi, which is negative 1. So that tells us we are going to start graphing when x equals negative 1, and we will end graphing when x equals negative 1 plus 2, which is 1. Right? We'll end graphing 1 period later. If you told me that c was positive pi instead, really the only difference is you'll start at 1 and end at 3. So you're just going to graph a different cycle than we did. You'll graph the second cycle. And again, that's not a big deal. That's okay. All right, so if we graph that, negative 1 to 1, we're going to go as high as a half and as low as negative a half. And the nice thing about this interval is the halfway point is 0. The quarter point would be negative a half, and the 3/4 point would be positive a half. All right. Sine functions usually start at the intercept, go maximum, back to the intercept, minimum, back to the maximum, or back to the intercept. Right? So if this is flipped over the x-axis, we will still start at the intercept, but then instead of going up, we'll go down. So we'll do intercept, minimum, intercept, maximum, intercept. Graph it looks like this. Double check the answer in our graphic calculator. Negative 1/2 sine pi x plus pi. If you look, start at negative 1, 0, and then we go down to negative a half, back to 0, up to a half, back to 0. Isn't it great? Are we having fun yet? Yeah. I can't think of a more fun thing to do than to graph different sine and cosine functions. I can't wait till we get to graph tangent, cosecant, secant, and cotangent functions as well. Okay. Questions? All right. So again, you can write any sine or cosine function in the form of a cosine bx minus c plus d. The last thing we have to talk about is what would a d value do to your function? And that's actually not so bad. It is your vertical translation. So it moves the graph up or down by d. The equation then, y equals d, is the midline of your function. So I'm going to give you a table. I don't know if this is something that you want to write down or not, but they asked for it earlier, so I'll give it to you too. So for any sine or cosine function, now that we know both the values for C and D, we can just use this table to determine where we will start graphing. So for sine, positive sine, you always start when your y value is 0. But since we are now being translated up or down, we will start where our y value is d. So we just wrote earlier that we start at c over b for our x, and our y value is now d. So we start at the intercept, but now that that's being translated up or down, we will start at that new midline. And then from that point, you should go up. For negative side, you will still start at the exact same point. The only difference is you go down afterwards. So instead of intercept maximum, we'll do midline minimum. For positive cosine graphs, you will start again, x value is c over b. We already have that in our notes. But cosine starts at its maximum point. So it starts at the a value. But since that is now being translated up or down by d, we will start at a plus d. That should be your maximum point. For negative cosine graphs, we will start, again, c over b for our x value, but we'll start at negative a plus d for our y value because negative cosine graphs start at the minimum. So again, you should be able to work out all of this as we do the step-by-step analysis. But sometimes I think it's been helpful for students to have that table. So for our example here, our a value is 3. That'll tell us that the amplitude is 3, which tells us that the range, I'm going to put an asterisk by this because it's not really the range, is from -3 to 3. And because this number is positive, we are not reflecting. Our b value for this problem is 2. And again, that's supposed to tell us what the period is, which would be 2 pi divided by 2, or pi. We do not have a c value, so there's no phase shift, there's no horizontal translation left or right. However, our d value is 2. So that tells us that we're being vertically translated up 2. So that tells us that we are going to start at 0. And because this is a positive cosine graph, 2 plus 3, or 0, 5. Is everyone okay with how I got 5? We start at the maximum, which is 3, but translated up 2 more. So we'll start really at 5. That means our range is really -3 plus 2 and 3 plus 2. So our range is really -1 to 5. And y equals 2 is our midline. Oh gosh, let me try that. I'm going to graph that up here since I ran out of room. Down there. All right, so we're going to start at x value of 0 and end at pi. Halfway point then would be pi over 2. Quarter way point would be pi over 4. 3/4 way point would be 3 pi over 2, or sorry, over 4. And again, you could get those intervals by taking the period and dividing it by 4. Every pi over 4 will transition. We're going to go, our range is from -1 all the way up to 5. And again, cosine, we're going to start at 0.5. So we will start at 0.5. And then the intercept is no longer at 0, right? The next point, our midline, is now at 2. So our middle is no longer at 0. It's been translated up to 2. And then we'll do minimum at -1. Back to the midline at 2, and then back to the maximum. So we get a graph that looks like this. Where this blue line y equals 2 is your midline, or like the center of your graph. So you can see this is starting to get pretty complicated to graph it by hand. It's not so bad if you go step by step, but there's a lot of steps. So I'm going to encourage you, for the first time you do these, or really every time you do these, just go to Desmos, graph it in there, and make sure that you did it right. I'm also going to graph the line y equals 2 so you can see. So if we look at this, the starting point was 0.5, like we had in our graph. And then at pi over 4, we're at 2, like we had in ours. At pi over 2, we're down to -1. At 3 pi over 4, we're at 2. And then at pi, we're at 5. So we matched all of the points in our calculator with the points that we drew by hand. Woo! All right. I would have liked to have done this example where we kind of work through the problems backwards. We find the parts and then write the formula. I think we'll do that as bell work tomorrow. I also would have liked to have done this where we do it in terms of a word problem too. I think you can figure out how to do these on your own, but if you're struggling with the homework, you might come back and look at these guided practices, try them on your own, and then check the answer, because I have the answer in the notes. Last thing I'm going to show you is some of your, I think there's one problem on there that tells you to do a sign regression, or they give you a set of data and they say, find the formula for that data set. That's not hard. You have done these before, so I'm just going to remind you how to do it. If you hit stat edit, that pulls up a list where you can add your data. And then if you hit stat and go to calc, it's just a new button. So we've done linear regressions, we've done quadratic regressions, we've done natural log, we've done exponential, we've done power, we've done logistic. New one is sine. So if they ask you to do a sine regression, it's just type into the calculator and you're doing a sine regression instead. All right. Questions about anything? Monday then is when this homework's due. Try your best on it. Use the read it, watch it, use your calculator to check your answer on a lot of them. Yeah. Have a good one. See you Monday. If you want to retake the quiz, let me know.